welcome to the 5th class overview of the Adonai gameplay animation workshop. Today we looked at creating blend spaces inside our animation blueprint and adding code to our player character so that they can interact with the animation blueprint. So first we looked at where we left off yesterday, which is creating a state machine, and inside the state machine we had an animation here. So here you can see we have a blend space put up. So the first thing we did was create a blend space. For that, you right click on the content browser, go under animation, and then select blend space 1D. Select the skeleton that you want to use, and then you can open it up. And as you can see, there are a lot of menus open in here. The primary ones that you need to be aware of are on the left side under asset details, where you can see the horizontal axis. Here you want to give it a name. We gave it speed because we're going to be doing an idle to walk and to run, and the only difference between them being how fast the character is moving. Then there's a minimum axis value and a maximum axis value. So this is going to define the variable and how much you can use the slider later on. The number of divisions refers to the amount of animations you can put inside it. So for 4 divisions, you can put 5 animations, and you can do it all the way up to 64. And you can put an animation on every single one of these divisions, although it wouldn't be recommended. You never really need that many animations. It's mostly for just blending purposes. And then we looked at interpolation. Interpolation exists in 3 types. One is average, so between 2 divisions, it's going to take the average of the animation. Then there's linear, which slowly goes towards the end, and then cubic, which goes a lot faster towards the end. And interpolation time is how long it takes for the animation to blend in or out. Okay, so the first one we did was idle, walk, and run. So we had the third person idle, and then we had third person walk, and then we had a third person run. So as you can see, when I move the slider, as the speed increases, the character walks, and if you further increase it, he starts to run. And this is the crux of what blend spaces are. I've already created them, so I don't need it, so I'm going to go ahead and delete it. Right. So we created 2 blend spaces. One of them was for walking and one of them was for crouching. The crouching one only has 2, one which is an idle and the other one which is walking forward. You don't need a sprint animation for the crouching because you can't really sprint while you're crouching. Okay, so let's look a little bit at the code of how we are managing the speed and the crouching part. So in order for us to find the speed, we created a variable inside the animation blueprint, and we are setting it after the event blueprint update animation. So this execute node works similar to event tick, that it constantly keeps going on as long as an animation is playing, and that's why we're using an isValid. Just in case this character isn't available, it's not going to constantly throw errors over and over again at us. The try get pawn owner refers to the player character this is actually being played on. So in our instance, it's going to be my player character that we created, the playable one. That's right there. Okay. Right. So here we are finding the speed of the character based on game physics. So we're getting the velocity of the actor. You see you get velocity, and then we're finding the vector length of that velocity. So these are 2 code blocks that you can just get it out from the right click menu. You should be able to find it with context sensitivity turned on. Um, or if you can't, then you can turn off the context sensitivity. It's right here. Um, anyway, and then you find the length, so that converts the vector. It solves the vector and gives us a float value, and that float value is going to be our character speed, which is what we're using. So whenever we go into our idle state, we can put the blend space here. This is the blend space. If you compile it, then like it should also showcase um, the slider itself and what you can do with it. So it's only a matter of compiling things. And then what we did was we dragged the variable here, and then we used get, and then we plug it in to the blend space. So now what it does is this variable, which is defined by the velocity of the character, is going to define what animation the character is going to be running. If it's going to be walking, if he's going to be uh, running, or if he's going to be idle. Okay, and then we looked at how we can switch between two states inside a state machine. So what we looked at is transition states. The way we do this is by clicking on the outer edge of a state, we drag out an arrow and create a new state. As soon as you create a new state, it comes with its own transition rule. These things are called transition rules. This is where you will be putting your code to define what will make this particular state to go into this particular state. And then if you want to have an arrow back to the original state, then you can also drag and do that. So we did that for crouch. And the way we did it inside the transition rules is that we created a Boolean variable, which is called animation blueprint is crouching. So as long as it's true, it will enter this transition. So if crouching is true, then it goes from idle to crouch. And the other side of it is ABP's crouching is not true. So as soon as crouching is no longer true, that's when this animation is going to go back to this one. And inside it is a similar blend space, exactly created the same way as we created the walk blend space, but instead it has the crouch animations. Okay, right. So now the only thing left is how we manage to hook up this variable to the blueprint itself. So last time we created a left shift for sprinting. Today we created a left control for crouching, and we're using a flip-flop. So a flip-flop is basically a condensed version of this entire code, where if you press one, it's going to go into a branch, and then the branch switches every time the input is run. A flip-flop basically does that, but every time there's an input, it's going to start with A, then it's going to go to B, then it's going to go to A. If you want to change that, you can also uh, switch it from this is a Boolean. So if you want it to start from B, usually it's only going to start from A, so you can just go ahead and do that. So now we have a separate variable. This is not the same variable as this variable. These are two completely different variables on two completely different blueprints. So now the way we have them interlinked is using a code function known as getActorOfClass. There are multiple getActorOfClass. If you search it, getActor. So there's get all actors of class, get all actors of class with this particular tag, and then get actor of class. So you can use get actor of class when you're only using one actor in a specific world. But for instance, if you're using multiple trees, or for instance horses, or there are a lot of farm animals, etc., then you can use get all actor of classes, and then out of which you're going to drag out the return node. So out of this return node, what this does is it allows you to access all the variables and everything that is available on the character blueprint. So that's how you get it on the animation blueprint. So this is the crouch. So if you search for is crouching, oops, yeah, get is crouching. This is the same is crouching as it is in here, which we turn on and off based on our left control. Okay. And then we simply just set it with the animation blueprint as crouching. So now both of these are interlinked. So now every time we press left control, it's going to go here. It's going to turn on the crouch, which is going to turn this this true, and that's going to turn this animation blueprint as crouching true, which is going to set this rule as true, which is going to make the idle go to crouch. And the same is true for the other way. So if you press left control again, then it's gonna uncrouch, and then it's going to make this false, and then this statement on the bottom is going to become true, so the crouch is going to go back to idle. So our end result looks something like this. Instead of our character constantly being in a T pose, he can finally walk around, and he can crouch. He can crouch and walk around too, and then he can also sprint. So yeah, that's all we learned for today. Tomorrow we're going to learn more about blend spaces and animation blending for different animations.